What's up, everyone? Welcome to episode 2, Hit VC Core Lessons. I'm actually excited about today's episode. We're diving into something that most people never think about. Most of the times when people think about AI, they think of chatbots, apps, models, but they don't think of the whole physical world behind the scenes. And so we're going to unpack a little bit of that, understand what data centers are, why do they require so much energy, and then at the end of that, we'll get into a founder fitness tip on powering your mind with the right energy. Let's go. Okay, so today's actually supposed to be a rest day, but I don't know, I get antsy, so I wanted to move around. So it's gonna be pretty light. We're gonna focus on lower body. I'm gonna do some squats, we'll warm up on the bike, might throw some kettlebells in there. But yeah, let's go. Most of the time on rest days, I like to do something that opens my body up, get into some yoga. Clearly, I'm not doing that today, but there's a good reason for that. Yeah, but typically I like to do yoga, something that opens me up. Like, again, if you're constantly sitting, hunched over, you want to do something that either incorporate some mobility stuff in your workouts or get to a yoga class. I'm terrible with like mobility and stretching. I'm just off with it. I need to go to a class, and that's what I typically do. But I already did yoga this week, so I thought I'd come in and get a very light workout in. So we'll just warm up here on the assault bike. And on a day like this, when I'm doing something a little bit lighter, I'll come and jump on the assault bike, and then I'll get into some of my stretches. I just kind of want to wake my body up, especially when it's cold like this outside. You come in, your body's super cold. You don't want to start stretching right away. You want to warm your body up a little bit, and then get into some mobility. All right, I'm gonna get into the stretching. Today's workout is a little bit hacky. Technically, I'm on my rest day, but when I have time like this, I literally just cobble things together. So I have a program that I follow. In my program, I have trap bar squats. So I'm gonna be doing that today. I'll get to like very moderate weight, and then I'll do jumping, trap bar squats, and I'll throw some kettlebell swings in there. So first, we'll start off with trap bar squats. We'll get into the jumping. All right, let's go. I'd say like moderately heavy squats. We're gonna do some jumping ones. Honestly, this is just more to keep my body athletic. It's something that I used to do when I played a lot of sport, or do this, Olympic lifts. So I kind of consider it in the camp of plyometrics, but whatever. Today's hacky, so kind of mix and match. Do 3 sets of those. And then we'll move on to kettlebell swings. All right, that's it. Workout is done, and now we're gonna get into the core lesson for today. Episode 2 of Core Lessons. And today we're gonna cover a topic that most people never ever think about which is all of the infrastructure and energy requirements that go behind AI. Most of the time when we're thinking about AI, we're picturing apps, chatbots, models, but the truth is behind every AI model is a massive physical world. So today we're going to unpack that. We're going to touch on it at a super high level, and then we'll get into our founder fitness tip. So starting off with data centers. So what is a data center really? If you think of software as the brain of AI, then data centers are the body, the muscle, the bone, the circuitry system that makes it all run. It's an engineered ecosystem. Inside, you'll find servers stacked floor to ceiling, connected by ultra-fast fiber. Each rack draws enormous amounts of power, which generates heat, and managing that heat is really an art form. Cooling systems circulate chilled air or even liquid directly around the chips. Backup power systems stand ready in case the grid fails, and security is tighter than most banks. Biometric scanners, armed guards, redundant fire systems, everything is built for reliability. They're designed to keep thousands of powerful machines running 24/7 without interruption, because in the world of AI, downtime is death. If the server stops, the intelligence stops. Every second of uptime is sacred. And the companies that are behind this world fall into a number of different camps. A few like Digital Reality specialize in building and operating these facilities, ranking them out as physical infrastructure. Then there are what we call hyperscalers. I'm pretty sure everyone's heard this term. These are giants like Amazon, Microsoft, Google, and Meta, who build their own data centers from ground up to power their global cloud networks. So why AI needs so much power? Let's talk about power because that's the heartbeat of it all. AI models are trained on vast data sets using GPUs or graphic processing units. Chips were originally built for gaming, but now repurposed as the engines of intelligence. Each GPU consumes a huge amount of electricity and emits an equally huge amount of heat. Multiply that by tens of thousands running in sync, and you start to understand why the energy footprint is enormous. Data center capacity is measured in megawatts. Now, a small one might use 5. A large-scale AI training site can draw over 100. To build that kind of facility, just the building costs over $1 billion. But here's the kicker. The equipment inside the servers, GPUs, and networking can cost 5 times more. Training a single cutting-edge AI model can consume as much electricity as powering a small town. And that's just one model. Yeah, a small town. So training versus inference. Now there's 2 main types of AI computation: training and inference. Training is when models learn, absorbing billions of data points over weeks or months. It's not latency sensitive, meaning it doesn't depend on speed of response or physical proximity to the user. So those massive training clusters can live anywhere with affordable power and land, places like Texas, North Dakota, or Iowa. Inference, on the other hand, is when models respond to you. So when you ask ChatGPT a question, or when an AI system helps a pilot, doctor, or driver make a split-second decision, that is latency sensitive. Those systems need to be close to users in major cities, near network hubs, so that AI feels instantaneous. That's why training clusters often live inland, near power and land, while inference clusters live near you, at the network's edge. Power constraint and innovation. The biggest bottleneck right now isn't chips, it's the power. In places like Virginia and parts of Texas, the demand for new data centers is outpacing what local grids can actually deliver. Utilities are overwhelmed with requests. Some projects wait years just for a substation connection. That's how high demand has become. To adapt, developers are getting creative. Some are adding on-site generation, small power plants dedicated to their own campuses. Others are exploring advanced cooling, energy reuse, even hydrogen turbines. It's basically industrial innovation at the edge of digital progress. We're witnessing the merging of 2 worlds, energy and computation, into a single strategic race, because whoever controls reliable, scalable power will control the future of AI. As a result of all this, there's a new class of company emerging, purpose-built to serve AI's unique hunger for compute. One of the most interesting examples is CoreWeave. They lease facilities, fill them with high-performance GPUs, and sell access to developers in AI labs who need specialized compute. It's like a tailor-made cloud for the AI generation, optimized for speed, density, and performance. CoreWeave started as a crypto mining company, but when AI took off, they pivoted, transforming their power-hungry infrastructure into something more valuable: intelligence infrastructure. Energy plus compute equals opportunity. So what does this mean for founders? For founders, this shift is profound. If you're building an AI, you're no longer just in software. You're in infrastructure. Every product decision now sits on top of physical realities: energy, latency, cost, and reliability. There's an opportunity everywhere, from power optimization and cooling systems to networking, scheduling, and the software that orchestrates all of this complexity. The frontier isn't just about building smarter models, it's about building the ecosystem that keeps them alive. Today's founder fitness tip is nutrition for cognitive performance. So just like data centers need clean, consistent energy to operate at their peak, so does your brain. What you eat directly impacts and shapes your focus, creativity, and decision making. Focus on quality fuel, steady energy from whole foods, hydration, nutrients that support brain health. So think of omega-3 fatty acids, B vitamins, magnesium, and antioxidants from fruits and greens, all of which help boost memory, focus, and cognitive endurance. This also helps you avoid spikes and crashes that come from quick fixes. But at the end of the day, consistency is key. Feed your brain the way you would fuel a world-class machine, because in many ways, it is one. Okay, that's it for the founder fitness tip. Let's go.